Hello everyone, myself Dr. B.B. Verma, Department of Applied Science and Humanity, AKGEC Engineering College, Ghaziabad. In today's lecture, we will discuss about the successive differentiation. In the successive differentiation, first of all, we will discuss about the differentiation. That is, what is differentiation? Differentiation is the process of finding the derivative, or differential coefficient is called differentiation. Now, we will discuss about the successive differentiation. The process of finding the nth derivative is called successive differentiation, or if we differentiate successively again and again the given function successively is called successive differentiation. If we have a function y equal to fx, then we differentiate again and again, that is the first derivative of y, it is denoted by d of y or d of f of x or f dash x or y1. The second derivative of y, it is denoted by d2 of y, d2 of y, d2 of fx or f double dash x or y2. Similarly, we can write or we can define or we can denote the nth derivative of y, it is defined by dny or dnfx or fn dash x or yn. Next, now we will discuss about the some standard formulas for finding the nth derivative. The first formula is the nth derivative or differential coefficient of y equal to x raised to the power m. The nth derivative of x raised to the power m is factorial m divided by m minus n factorial into x raised to the power m minus n, or it is denoted by yn. Yn is defined by factorial m divided by m minus n factorial into x raised to the power m minus n. If we have n equal to m, it means both the values are equal, then the value of the mth derivative or nth derivative of x raised to the power m or x raised to the power n is d raised to the power m of x raised to the power m equal to m factorial divided by m minus m factorial into x raised to the power m minus m, that is m factorial divided by 0 factorial into x raised to the power 0 equal to m factorial, because of 0 factorial is 1 and x raised to the power 0 is 1. The second standard formula for n derivative of ax plus b whole raised to the power m. So, value of nth derivative of ax plus b whole raised to the power m is m factorial divided by m minus n factorial into a raised to the power n into x raised to the power ax plus b whole raised to the power m minus n. In this formula, if we have m or n both are same, so the nth derivative of ax plus b whole raised to the power n equal to n factorial divided by n minus n factorial into a raised to the power n into ax plus b whole raised to the power n minus n, that is factorial n upon 0 factorial into a raised to the power n into ax plus b whole raised to the power 0, ax plus b whole raised to the power 0, that is 1, and factorial 0 is also 1. So, value will be a raised to the power n, a raised to the power n into factorial n. The third formula for finding the nth derivative of ax plus b whole raised to the power minus 1 or 1 upon ax plus b. In this formula, the value of the nth derivative, it is denoted by dn over dxn of ax plus b whole raised to the power minus 1 or capital D raised to the power n of ax plus b whole raised to the power ax plus b whole raised to the power minus 1. This will be minus 1 raised to the power n into n factorial into a raised to the power n divided by ax plus b whole raised to the power n plus 1. In the fourth formula for finding the nth derivative of ax log of ax plus b, the value of the nth derivative of log of ax plus b is minus 1 raised to the power n minus 1, n minus 1 factorial, a raised to the power n, ax plus b whole raised to the power n. This is the formula for finding the nth derivative of log of ax plus b. Similarly, we can use or we can find the value of the nth derivative of e raised to the power ax plus b, that is exponential function. So, it is denoted by dn of e raised to the power ax plus b equal to a raised to the power n into e raised to the power ax plus b. And next formula for finding the nth derivative of a raised to the power x. The value of nth derivative, that is d raised to the power n into a raised to the power x, this will be a raised to the power x into log of a whole raised to the power n. This will be the value of the nth derivative of a raised to the power x. Now, we use these standard formula for finding the nth derivative in some problems, in some questions. If we have a function 1 upon 6 into x raised 6x square minus 5x plus 1, and then find the value of the nth derivative of this function, because we know that the nth derivative of any linear factor of algebraic function. But in this question, in this problem, we have quadratic polynomial. So, first we convert this quadratic polynomial into linear polynomial. So, we can factorize this quadratic polynomial into two linear factors. Here, two linear factors of 6x square minus 5x plus 1 are 2x minus 1 into 3x minus 1. These are the two linear factors. But we know that the formula for finding the nth derivative of single linear factor. But in this question, in this problem, we have product of two linear factors. So, first we convert this quadratic function into single algebraic function, a single linear factors. So, we use partial fraction. We use the partial fraction a upon first factor, a upon 2x minus 1 plus b upon 3x minus 1, and after simplifying we will get the value of a is 2 and value of b is minus 3. So, we have y equal to 2 upon 2x minus 1 plus minus 3 upon 3x minus 1. We can write these two values in this form, that is 2 into 2x minus 1 whole raised to the power minus 1 minus 3 into 3x minus 1 whole raised to the power minus 1. Now, we know that the formula for finding the nth derivative of ax plus b whole raised to the power minus 1, and value of this formula, value of this derivative, nth derivative, is minus 1 raised to the power n into n factorial into a raised to the power n divided by ax plus b whole raised to the power n plus 1. So, now we use this formula for finding the nth derivative of this function. So, we operate dn on both sides of the function. So, left side is denoted by yn, and dn of 2 into 2x minus 1 whole raised to the power minus 1. Minus d raised to the power n into 3x minus 1 whole raised to the power minus 1. So, value of the nth derivative of 2x minus 1 whole raised to the power n minus 1 minus 1 is minus 1 raised to the power n, 2 raised to the power n factorial 2x minus 1 whole raised to the power minus n minus 1. The value of nth derivative of this function is 3 raised to the power n minus 1 raised to the power n factorial 3x minus 1 whole raised to the power minus n minus 1. And after simplifying, the value of the nth derivative of y, that is yn, is minus 1 raised to the power n factorial into 2 raised to the power n plus 1 divided by 2x minus 1 whole power n plus 1 plus 3 raised to the power n plus 1 divided by 3x minus 1 whole raised to the power n plus 1. So, this will be the required value of the nth derivative of given function, that is nth derivative of 1 upon x 6x square minus 5x plus 1 is this. Again we find the nth derivative of tan inverse x upon a, because in this question we are given the function tan inverse of x upon a, but we don't have the formula for finding the nth derivative of tan inverse. So, first we convert this trigonometrical function into algebraic function. So, we differentiate first time the given function tan inverse x upon a. So, first derivative of tan inverse x upon a is a upon x square plus a square equal to a upon x plus I a into x minus I a. Because x square plus a square have two factors x plus I a and x minus I a. Now, we use the partial fraction a upon x plus I a plus b upon x minus I a. Here a equal to minus 1 and b equal to minus 1. So, value of y1 is 1 upon 2i into 1 upon x minus ia minus 1 upon x plus ia. This will be the equation 1. Because of this is the value of first derivative, but we find that the value of the nth derivative. So, equation 1 differentiate n minus 1 times with respect to x. So, we operate dn minus 1 on both sides. So, dn minus 1 of y1, that is y dn of y or yn, and 1 upon 2i into dn minus 1 of 1 upon x minus ia minus dn minus 1 of 1 upon x plus ia. So, derivative of 1 of dn minus 1 of 1 upon x minus ia is minus 1 raised to the power n minus 1 into n minus 1 factorial divided by x minus ia whole raised to the power n minus 1 raised to the power n minus 1 factorial x plus ia whole raised to the power n, and after simplifying the result, after simplifying the value of nth derivative, that is yn is 1 upon 2i into minus 1 raised to the power n minus 1 factorial into 1 upon x minus ia minus 1 upon x plus ia. So, this will be the final result of nth derivative of tan inverse x upon a. in terms of algebraic, but we can find the value of the n derivative in terms of r and theta. So, we further we put the value of a and x in terms of r and theta. Now, we put x equal to r cos theta and a equal to r sin theta, then a equal to r equal to a upon sin theta and theta equal to tan inverse a upon x. Putting these values in equation 3. After putting these values, we will have the value of the nth derivative as 1 upon 2 ia into minus 1 raised to the power n minus 1 into n minus 1 factorial. The value of x, that is r cos theta, minus I into a equal to r sin theta whole raised to the power minus n, minus x equal to r cos theta, plus I into a equal to r sin theta whole raised to the power minus n. Because r raised to the power minus n as a common, so we take outside the bracket. So, while value of yn is 1 upon 2 I into minus 1 raised to the power n minus 1 factorial as it, this value will be as it is, and after taking r raised to the power n minus n, take common, so r raised to the power minus n into cos theta minus I sin theta whole raised to the power minus n, minus r raised to the power minus n into cos theta plus I sin theta whole raised to the power minus n. We all know about the de Moivre theorem of the trigonometrical function. So, we can use the de Moivre theorem. So, power of this bracket is minus 1 minus n, we can use in the product of theta. So, the value of yn is 1 upon 2 I into minus 1 raised to the power n minus 1 factorial r raised to the power n into cos n theta, cos minus n theta, that is cos n theta, minus I into sin minus n theta, minus sin n theta will be minus sin n theta, minus plus. So, minus cos n theta minus I sin n theta, these are cancel out. Cos sin theta minus plus sin theta into I sin theta, cos theta cancel out. So, value of yn is 1 upon 2 I into minus 1 raised to the power n minus 1 factorial into a upon sin theta whole raised to the power minus n into 2 I sin n theta. So, this will be the final result in terms of r and theta. So, yn equal to minus 1 raised to the power n minus 1 factorial divided by a raised to the power n into sin n theta. Now, we will discuss one more example, one more question for finding the nth derivative. In this question, we have a function y equal to tan inverse 2x upon 1 minus x square, and then find the value of nth derivative. So, first of all, we arrange the given function y equal to tan inverse 2x upon 1 minus x square. Tan inverse 2x upon 1 minus x square, we can write 2x in 2x is the sum of x plus x, that is 2x equal to x plus x divided by 1 minus x square, that is 1 minus x into x. And we know that the formula of tan inverse x plus tan inverse y is tan inverse x plus y divided by 1 minus x into y. Here tan inverse x plus tan inverse x, that is twice time of tan inverse x. Twice time of tan inverse x. So here we can write the given function in terms of 2 into tan inverse x. But we can't have the formula for finding the nth derivative of tan inverse x. So we convert this tan inverse x into algebraic function. To convert into algebraic function, we differentiate the tan inverse x. So first derivative of tan inverse x is y1 equal to 2 into 1 upon 1 plus x square, 1 upon 1 plus x square equal to 2 upon the linear factor of 1 plus x square or x plus I and into x minus I, x minus I. So we can use the partial fraction for finding the value of a and b. After using partial fraction, the value of a is value of a is plus 1 and the value of b is minus 1. So we can write the first derivative of a given function into 1 upon I into 1 upon x minus I minus 1 upon x plus I. Because this is the first derivative, but we find the nth derivative of given function. So we differentiate n minus 1 times of y1. So we can operate d raised to the power n minus 1 on both sides. So d raised to the power n minus 1 of y1 and d raised to the power n minus 1 of y1 upon x minus I minus d raised to the power n minus 1 of 1 upon x plus I. We know that the n minus 1 is the derivative of x minus 1 upon x minus I and d raised to the power n minus 1 of 1 upon x plus I. Both are the value of n minus 1 at derivative of 1 upon x minus I is minus 1 raised to the power n minus 1 factorial divided by x minus I whole raised to the power n minus 1 raised to the power n minus 1 into n minus 1 factorial divided by x plus I whole raised to the power n. This will be the n minus 1 at derivative of 1 upon x plus I, or this is the value of this term. After simplifying, the value of yn, that is nth derivative, equal to 1 upon 2I into minus 1 raised to the power n minus 1 factorial into 1 upon x minus I whole raised to the power n minus 1 upon x plus I whole raised to the power n. Again we write the value of the nth derivative, yn equal to 1 upon I into minus 1 raised to the power n minus 1 factorial x minus I whole raised to the power minus n and minus x plus I whole raised to the power minus n. Again we put x equal to r cos theta and 1 equal to, because of the coefficient of I is 1, so we put 1 equal to r sin theta and theta equal to tan inverse 1 upon x, putting these values in equation 2. So after putting these values, the value of yn is 1 upon I into minus 1 raised to the power n minus 1 factorial r into cos theta minus I into r sin theta whole raised to the power n minus n minus r into cos theta plus I into r sin theta whole raised to the power minus n. After taking the common r raised to the power minus n, so r raised to the value of yn is 1 upon I into minus 1 raised to the power n minus 1 n minus 1 factorial r raised to the power minus n cos theta minus I sin theta whole raised to the power minus n minus r raised to the power minus r raised to the power n minus r raised to the power n minus n cos theta plus I sin theta whole raised to the power minus n, and after simplifying or using the de Moivre theorem, the value of yn is 1 upon I into minus 1 raised to the power n minus 1 factorial r raised to the power minus n cos n theta plus I sin n theta minus cos n theta minus I sin n theta, and after simplifying the value of cos n theta both are cancelled. So yn equal to 1 upon I minus 1 raised to the power n minus 1 factorial 1 upon sin theta whole raised to the power n, because the value of r is 1 upon sin theta. So 1 upon sin theta whole raised to the power minus n into 2I sin theta n theta. That means the value of yn, it means nth derivative of tan inverse 2x upon 1 plus x square will be 2 into minus 1 raised to the power n minus 1 factorial into a raised to the power n into sin raised to the power n theta and sin n theta, where theta equal to tan inverse 1 upon x. Now we will discuss about the next problem. In this problem, if we have y equal to sin mx plus cos mx, then show that the value of nth derivative of y is m raised to the power n into 1 plus minus 1 raised to the power n into sin 2mx whole raised to the power 1 by 2. It means under root of m raised to the power n plus m raised to the power n into 1 plus minus 1 raised to the power n into sin 2mx, because we have y equal to sin mx plus cos mx. This will be the equation 1. Now we differentiate equation 1 n times with respect to x, because we find the value of nth derivative of y. So we differentiate n minus 1 n times of a given function. So we use d raised to the power n for finding the nth derivative on both sides. So d raised to the power n of y into d raised to the power sin mx plus d raised to the power n into cos mx. We know that the nth derivative of sin ax plus b equal to a raised to the power n into sin ax plus b whole ax plus b plus n into pi by 2. This will be the formula for finding the nth derivative of sin ax plus b. Here a is the coefficient of x and b is the constant. Here in this function the coefficient of x is m, so value of the nth derivative of sin mx plus c will be m raised to the power n sin mx plus n into pi by 2. Similarly, we can find the value of the nth derivative of cos mx. The value of the nth derivative of cos mx is cos mx plus n pi by 2 into m raised to the power n, because m raised to the power m as a common in both the term. So we take outside the bracket, and value of y n is m raised to the power n into sin square mx plus n pi by 2 plus mx plus n pi by 2 plus cos mx plus n pi by 2. We squaring and taking the under root, because we show that the resultant, it means the value of the nth derivative in terms of under root. So we can squaring on both, we can squaring and taking the under root. So the value of a square of a sin mx plus n pi by 2 plus cos mx plus n pi by 2 whole square, the value of this term will be sin square mx plus n pi by 2 plus cos square mx plus n pi by 2 plus twice time of sin mx plus n pi by 2 into cos of mx plus n pi by 2 whole raised to the power 1 by 2. The value of sin square mx plus n pi by 2 plus cos square mx plus n pi by 2, this will be 1. The value of sum of these two terms will be 1. So 1 plus and 2 into sin mx plus n pi by 2 into cos mx plus n pi by 2, this will be the 2 sin a cos b. So this will be converted into 2 sin mx plus n pi by 2, and value of the first two terms will be 1. So value of nth derivative is y raised to the power n into 1 plus sin 2 mx plus n pi by 2 whole raised to the power 1 by 2 equal to m raised to the power n 1 plus sin 2 mx plus n pi whole raised to the power n whole raised to the power 1 by 2. So the value of the nth derivative, that is the value of yn, will be m raised to the power n into 1 plus minus 1 raised to the power n into sin 2mx plus 2mx whole raised to the power 1 by 2, because of sin 2mx plus n pi, this will be the minus 1 raised to the power n into sin 2mx, because sin pi plus x is minus sin x. So this will be the final result. Thank you.